So now we're gonna be using NTP in all networks. Everybody pretty much uses NTP. NTP allows for a network device to synchronize its date and clock with the current time around the globe, of course with a specific time zone, the time zone you get to choose, by default being GMT. And NTP runs over UDP 123, cannot run over TCP or any other means, at least up to this point. It only works over UDP 123, both source and destination ports being UDP 123. Now, why do organizations implement NTP in the network? Because the time on the router or on the network device in general is crucial for certificate validation, for example. So like if that router is gonna do any kind of certificate validation, like for IPsec VPNs, SSL VPNs, or pretty much I would state pretty much those are the use cases. If the router has to do any kind of certificate validation, then it has to make sure that the time is accurate, because otherwise it may result in either in validating a certificate which is actually invalid, is not within the time window of its validity, or is going to end up believing that actually a certificate which is valid is going to be considered not valid because the router's clock time is way behind or way after, way ahead of the current time around the globe. Can also be used for time-based access lists. So like we have defined before, an access list, you can also configure time-based access lists, which means they're going to be enforced and activated at specific intervals as you configure them. So the use case here being back in the days where we didn't have the current, let's say today's tools in order to restrict users' access to the internet. Like back in the days, a lot of years ago, this was a very good tool in order to configure an ACL, which for example blocked all traffic towards the internet after 6 p.m. for example. So for that point, nobody should be within the company's network on the inside. So it means that all internet traffic was dropped just to make sure, for example, that nobody was leaking traffic from the inside of the network towards the internet. So you would configure that time-based ACL to drop all traffic from the LAN towards the outside world at specific time intervals. Log file analysis and correlation by remote intelligence like CM or big data analytics solutions. So if you want a CM or a big data security analytics solution to be able to correlate correctly any kind of log messages and identify any kind of attacks in the network, then you want to configure your log messages to be time-stamped with the current time of the router. And in order for that intelligence to be able to identify an attack or not, you would want the log message to have an accurate time and date stamp attached to it. So that's why, because you would want the syslog messages to be stamped with the router's time and date, but that has to be also accurate, then that's why you would want to have your network device to synchronize its time and date via NTP. Now iOS supports both the roles of NTP client and NTP server. Authentication is also being available via MD5 as per the RFC. Now of course, depending on how accurate basically what I'm trying to say is that the router or any kind of network device can act as a NTP server, but it's not going to be as accurate as dedicated NTP servers because of their stratum level. So a stratum level defines the accuracy of a time source. And the lower the stratum level, like 0 or 1, it means that the more accurate the time source is. And any kind of network devices in general, you cannot configure a stratum level of 0 or 1, which is the atomic clock, because that's a very accurate time source, and the network device lacks the proper hardware to be able to perform as a stratum 0 or 1 accurate time source. But if let's say the time source, it doesn't matter if it's accurate within a couple of milliseconds, or 1 second or 2 seconds, then you can use a network device to be your NTP time source. But companies that really want security to begin with, they actually implement in the network dedicated NTP servers which support the atomic clock stratum level of 0 or 1, which means first of all that the time is going to be very, very accurate. And also, don't make the mistake to synchronize your NTP, your routers, your network devices with a public NTP source, because that's easily if you synchronize your network devices with a public NTP server, then imagine that NTP server, because it's public, it can be easily attacked and its time source can be changed. So ideally, if you want to be secure, you're going to always have your NTP source in the network, which means to make sure that source is accurate, you actually need a dedicated NTP or dedicated basically time source, which is a dedicated appliance to perform that role.